Hi friends, welcome to this tutorial on Git Basics, your first repository and commit. If you are new to the world of version control or just starting to work with Git, you have come to the right place. In our previous episode, we covered how to install and configure Git. Now, in this video, we are going to build on that foundational knowledge and cover the essential steps to get you up and running with your first Git repository and commit. We will start by learning how to initialize a new repository, understand the basic Git workflow, stage files for your first commit, and finally make your very first commit. We'll dive deeper into the best practices for committing changes. Git is a powerful tool that has become the industry standard for version control, and mastering the basics is the first step to becoming more efficient and collaborative developer. So, let's dive in and get you started with your Git journey. We can obtain the Git repository in one of the two ways. We can turn any local folder into the Git repository, or we can copy the Git repository from elsewhere. This term is called cloning a repository. For example, cloning a repository from GitHub. Here I am going to focus on initializing a local Git repository. First of all, I'm gonna create a project directory. You can call it anything and place it anywhere in your computer. Here, I am in my project directory. This is the directory where I usually put all of my projects. Let's create a new directory. The command for creating a new directory is mkdir, which is short for make directory. Then space. Now, name of the directory that we want to create. Let's say the directory name is learning_git. Now go into this directory. Imagine this is our coding project. This will contain tens or hundreds of files. Now to enable Git to track the files of our project, first we need to initialize the Git repository inside this directory. To do this, while inside this project directory, run the command git space init. See the output here. Initialized empty Git repository in. Here is the full path. So we have learning Git directory, and inside another subdirectory .git have been created. If you check the list of files using the command ls, you see no files or directories are listed. But we have just noticed a new .git repository has been created. Why is that? By default, this is a hidden directory. You are not supposed to touch it. If you run the command ls space -a, this a flag is telling to show all the files. Here you can check the .git folder. Let's open the .git directory. Open .git. So here is the Git directory or Git repository where Git stores the information about our project history. Here we have directories like hooks, info, objects, refs, files like config, description, and head. We actually do not need to understand the structure. These are purely implementation details. That's why this directory is hidden. We never need to touch it. If you remove this directory, you will lose your project history. So it's important. Alright, now we have our project directory and a hidden subfolder inside it that holds the Git repository. Git is now all set to track any changes we make to our files. So whenever we add a new file or make changes to existing ones, Git will keep track of everything. When we reach at the point that we want to record the repository, we can create a commit. Think of a commit as taking a snapshot of the project at the exact moment of the time. But before committing, there is a step in between that is called staging area, also known as index. The staging area is where the changes are prepared for the next commit. The staging area is like a holding zone where we can review the changes we want to commit. If more changes are required, we can easily remove the file from the staging area and modify things before committing. If everything looks good, we commit the changes and they are permanently saved in the Git repository. In Git, every file falls into one of the two categories, tracked or untracked. Tracked files are those that Git is monitoring either because they have been staged for the first time or they were part of the most recent commit or snapshot. On the other hand, untracked files are files that have not been committed or staged yet. These are new files that Git has not started tracking. Now let's break it down further. Tracked file can have one of the three status: unmodified, modified, or staged. For example, when you clone a repository, say from GitHub, all files will be tracked and unmodified because Git just checked them out and no change have been made yet. In our case, since we have just created a new Git repository, adding a new file will mark it as untracked because it has not been committed or staged. To track this file, we need to add it to the staging area using the command git add followed by the file name. This moves the file to the staged state, and from that point, Git will track any changes made to it. When we commit, Git stores a permanent snapshot of the file in the repository. After this commit, the file becomes tracked and unmodified. If we edit the file after the commit, its status changes to modified, and the cycle continues as we stage and commit further changes. Now let me show you this in action. Let's open our learning_Git repository in Visual Studio Code. As you can see, it's currently empty. No files here yet. Let's add a new file called readme.md, and inside it we will add the text hello world. Next, let's check how Git sees this new file. Visual Studio Code comes with a built-in terminal which I will use so that I don't have to switch back and forth between VsCode and my macOS terminal. So open the terminal, press Command plus Option and tilde. Our terminal is now open. We can determine the status of the file using the git status. As you can see, Git is showing that readme file is untracked. This is because we have just added a new file. Git sees this file was not part of my previous snapshot, nor has it been staged yet. So Git considers it as untracked. Git won't track this file or include in any snapshots or commit until you explicitly tell it to. This behavior ensures that you don't accidentally include any binary files or other files that you didn't intend to track. In our case, I want to start tracking this file, so I am going to stage it. We can do that using the command git add followed by the file name. You can explicitly specify the file name or use patterns, for example star.md. This will stage all files with a .md extension, or you can use a wildcard like a period. This command will add all the files in the directory recursively. However, be careful when using the wildcard, as it may end up including files you don't intend to track. In our case, since we only have one file to track, it's safe to use the period. Now if you run the command git status, you can see this readme.md file is now tracked and staged to be committed. You can tell the file is staged because it appears under the changes to be committed heading. If you commit now, the version of the file as it was when you run git add command is what will be stored in the repository. We can commit the changes using the command git commit. Now you will see that a new tab commit_edit message opens in Visual Studio Code. In the terminal, you will see the message waiting for your editor to close the file. Git is waiting for you to enter a commit message in this file, save it and close it. After closing the file, Git will take the snapshot. Let me show you how this looks like from my macOS terminal. I will close the Visual Studio Code for now. Here is my terminal opened. Since I am already in the learning Git directory and the file has been staged, if I run the command git commit. This will again open Visual Studio Code with the commit_edit message tab. And the terminal displays waiting for your editor to close the file. Here, we need to provide a commit message, which is a short description of the changes we have made. Commit messages are important. They should provide a brief description of what you have done. These messages help you track history and easily understand what changes were made at each point. I will talk more about writing effective commit message later. For now, let's close the editor without adding a message. You will see the terminal now says aborting commit due to empty commit message because we did not provide one. There is also a shorthand for committing with a message. The command is git commit -m. M is shorthand for the message. Then provide the commit message inside double quotes. Let's say it is an initial commit. After hitting enter, the file is committed to the repository and Git provides some output. The branch where the commit was made, the SHA-1 checksum of the commit, which acts as the unique identifier, how many files were changed, and statistics about lines added or removed in the commit. When you commit, Git stores a unique identifier for that commit called the SHA-1 checksum. You have just seen this in the command prompt after making the commit. Along with this, Git also stores the commit message, the timestamp of when the commit was made, who made it, and the complete snapshot of the project at that moment. This is a key difference between Git and most other version control systems. Instead of just saving the changes, which is called delta-based version control, Git saves the entire content of the project at each commit. This allows Git to quickly revert back to any previous state. You might think, does not saving a full snapshot every time waste a lot of space? No, not really. Git is highly efficient. It compresses the files and does not store duplicates. So, even though it takes full snapshot, Git ensures minimal storage usage. This is all handled behind the scenes. So, you don't need to worry about this. It takes care of the details for you. At this point, a snapshot of our README file is stored in the repository and its status is now tracked and unmodified. Next, let's modify the file and see what happens. Add a new line to the README file. Now check the file status by running git status. You will notice the README file appears under the changes not staged for commit section. This indicates the file, which is already tagged, has been modified in the working directory but has not been staged yet. To stage the change, run git add then period. This command stages the modified content for the next commit. It's important to understand that you are not adding the file itself, but rather telling Git to track the exact changes made to it for the next commit. Now let's add another file to the directory. Creating a new file, contributing.md. If you run git status now, you can see this file is under untracked files. We can tell Git to track using the command git add then the file name contributing.md. If you check the git status now, you can see both files are staged and will go into your next commit. At this point, let's say you realized you need to make one small changes to your README file before committing. No problem. Open the file again and make the changes. I'm just adding a new line. Now, if we run git status again, you will notice something interesting. The README file appears in both staged and unstaged section. What's going on here? Well, when you run the git add command, Git stages the file exactly as it was at that moment. If you commit now, Git will store the version of the README file from last git add, not the version currently in your working directory. In other words, If you modify the file after staging it, those new changes are not included in the commit until you stage the file again. Now, let's fix that by running git add once more to stage the latest changes and commit. Let's add a commit message. Now, let's talk about best commit practices. First of all, why you should care about commit quality? Well, clear informative commits make collaboration smoother, simplify debugging, and create a useful project history. Your future self and obviously your teammate will thank you. So, here are some best practices of commit. Don't wait too long to commit your changes. Smaller, more frequent commits make it easier to track changes and isolate bugs. But don't go overboard. Avoid committing incomplete work or random snapshots. Each commit should represent a logical and working state of your code. A good commit message clearly explains what changed and why. Avoid vague messages like fixed stuffs or update code. Instead of fixed bug or updated files, aim for clarity like fixed off by one error in user login validation or refactored product API to support pagination. Use the imperative mode. Start your commit messages with a verb as if you are giving a command. For more complex changes, use a short subject line, usually 50 characters or less, followed by a blank line and the more detailed explanation. I will show you an example of this later. Keep your repository clean by only committing the source files, not files that are generated from those sources, like binary files or logs. Keep related changes grouped in a single commit. If you are fixing a bug, refactoring a code, and updating documentation, don't do it all in one commit. Separate those into different commits so that each one is focused on a single responsibility. This makes reviewing the changes and debugging a lot easier. Now, let me show you good commit message example. Here you can see the subject of the commit is add user authentication to API, followed by a line break, and then it has some short description of what it has done. This commit message clearly describes what was done, provides some details, and reference an issue number. Remember, good commit practice are not just about following rules. They are about clear communication and creating a useful history of your project evaluation. Great job! We have covered the essentials of creating our Git repository and making our initial commit. We have learned how to initialize a repository, understand Git's workflow, stage file, and create our first commit. In our next video, we will discuss how to skip the staging area if necessary, view staged and unstaged changes, and use the short status command for quick insights. Stay tuned to enhance your Git skills further. Happy coding!